Hello, thank you so much for your time. My name is Darlin Fee. This is the second part of the integration by partial fraction fundamentals. And so, if you watch the first fundamental, you also need to watch this second fundamental so that when we get to the part 3 where we are going to do the proper integration by partial fraction, you will not find yourself in difficult situation. I am Darlin Fee, and please make sure you subscribe to this channel. Now, by the end of this presentation, you should be able to integrate 1 over x plus 2 dx, and then 3 over 6x minus 5 dx, and the rest. So before we move on to the second fundamental, it is important for us to understand some standard integration. So the first example is a standard integration that we need to know. So the integral of 1 over x plus 2 dx. When you integrate this by standard, you are going to get the natural log of the absolute value. Then whatever denominator you have down, you place inside the absolute value symbol, and then plus c because this is indefinite integral. That is, the top must be 1 and then the down must be some algebra. And so because I have 1 here and then I have some algebra here, the standard integral is natural log the absolute value of the denominator you have, that is x plus 2, in the absolute value plus c. Then another key important takeaway that we need to also understand is the second example. So the integral of 3 over x minus 7 dx. Now remember, the standard says that the top must be 1, but here we have the top not being 1, it is 3. So in a situation where the top is not 1, it is 3, you have to factorize it to come outside the integral sign. So when I come to this step, you realize that this 3 has been taken out, and if 3 is removed, what will be remaining here is 1. So on the right hand side, you see that the 3 is outside the integral sign, and then we have 1 over x minus 7. Then we can apply this standard integration here. So when you integrate this, it is going to be the natural log absolute value of whatever you have down here. So that is the x minus 7 in absolute value plus c. Now the 3 that you brought outside is going to multiply the natural log. This is another important key takeaway that we need to understand as we move on. Then the last one is this. So we have the integral of 3 over 5x minus 5. Now here notice that the top is 3, and then where the x is, there is another number attached to it. In the first two examples, no coefficients was attached to the x. Here too, no coefficients was attached to the x. Okay, but in this case, there is a coefficient of 5 attached to the x. We apply the same concept as we did in step 1 and in step 2. How do we do it? First, you factorize the 3 out. So if this 3 comes outside, what will be left here is 1. So if you have 1 over 5x minus 5, then if you are integrating that 1 over 5x minus 5, remember, already you have factorized this 3 outside. So when you integrate the 1 over 5x minus 5, you are going to get the natural log absolute value x minus 5 plus c. Okay, so the question is, where from these extra figures? Now this 3 was the 3 that you factorized outside. Remember, here we had a 3 coming to multiply the natural log. So that 3 is what you see here. If this number were to be 6, then this would have been 6. Whatever number you have here, that same number will be repeated here. Then the next question is, where from 1 over 5? Now it's simply so because 1, let's go to the top. When we integrate, when we find the derivative of x, we'll get 1. When we find the derivative of this x2, we'll get 1. But when you find the derivative of this 5x, you will not get 1. You are going to get 5. Alright? And so it is going to, because you are going to get 5, we are going to write it 1 over that 5. So this 5 is coming from the differentiation of the 5x. That's how come we got this 5. And so now we multiply 3 times 1 over 5, and we are actually getting 3 over 5, and then we have the natural log of natural log of 5x minus 5, and then plus c. So once you have understanding of this takeaway, then we can move on and then solve the questions that follows. Thank you. Now first of all, look at this. Evaluate the integral of 1 over x plus 2 dx. Now by fundamental definition, okay, or by the standard of integration, what it means is that when you have 1 over x plus 2 and you are integrating, ideally the number here will come out. But if it is 1, there is no need to write that 1. But if the number at the top is more than 1, then it will come out. So the definition simply states that the integral of 1 over x plus 2 dx will give you the natural log of x plus 2. So that's what you have here. So when you integrate this, you are getting the natural log of x plus 2. Remember, I told you that if this is 1, then you ignore it, because if you place 1 here, it is still the same thing. But if the number here is more than 1, let's say if this one were to be 2, then you will have 2 natural log of absolute value x plus 2, then plus c. Remember, it is c because this is an indefinite integral. So this is another fundamental that you need to understand, because we are going to do application in the part 3. So if you are good, then let's move on to the second example. Now the next one, we have this. Determine the integral of 6 over x plus 2 dx. So look at this. Here we have 6 here, and then we have divided by x plus 2. Remember, as I said earlier, this 6 is what I have here in the blue color, and we are integrating this. So when I pick the 6 out and I bring it here, I am going to get 1 over x plus 3. And per the standard, the integral of 1 over x plus 3 is going to give you the natural log of x, the absolute value x plus 3. Let's get that right. But because this is 6, so the 6 will now come out. And so we have this 6 here. Now, supposing it was 1, then the 1 wouldn't be written here because it will not make any sense. But if the number at the top is more than 1, whether positive or negative, that number must always be written here. And then the standard says that 1 over x plus anything, when you integrate it, you are getting the natural log absolute value of whatever you see down here. So what I have here, x plus 3, is what you are seeing here. So it must be in absolute value. So that is absolute value of x plus 3. And then because we are dealing with indefinite integral, you add the plus c to it, and we are good to go. Okay, so the next question, we have evaluate the integral of 3 over 6x minus 5 dx. Now, if you have paid attention to what we have done, the standard integral says that the top must always be 1. And so how do we ensure that this become 1? we can do so by factorizing the 3 outside the integral sign. So when you come to this side, I have the integral of 3. This time 3 is in green for a specific reason, divided by 6x minus 5 dx. Now because this 3 is more than 1, I factorize it outside the integral sign. So this 3 is what we see here. Now if you take 3 out, what will be remaining here is 1. So we have 1 here. Don't forget that this 1 times this 3 will give us 3. But then we want to follow the standard integral procedure where this side must be 1 for the fundamentals. And so this 3 is out. And from what you have seen so far, the integral of 1 over 6x minus 1 is actually going to give you the natural log of 6x minus 5. Remember that. So the integral of 1 over 6x minus 5, all you need to do is that you bring the natural log, and then there must be the absolute value, and then whatever denominator you see here, you put the same thing here. Now the question comes across, yes, I understand this 3 in green color is what I have here as 3. Where from this 1 over 6? Well, now you see that the 6x here, this one we can actually find its derivative. We can differentiate this, and when you differentiate 6x, you are going to actually get the coefficients of 1 over 6. So that explains why we have, so this 1 over 6 is the coefficients when we differentiate this. Okay, so we have 1 over 6, and so that's how come we got this. And then as usual, because we are dealing with the indefinite integral, you need to introduce the c to it. Now let's come and think about this carefully. You see that 3 actually goes into 6 2 times, and so we are going to have 1 over 2. So when you come to the final answer here, I have 1 over 2, and then the natural log, absolute value 6x minus 5, and then plus c. And this makes it very easy. And all you need to understand, okay, is this, that the standard integral of any function 1 over any polynomial is simply going to give you the absolute value of the polynomial, which is the denominator. That is all. That is all. So if here were to be x plus 20, would have had natural log absolute value x plus 20. But then if the number at the top is more than 1, then that number will now come outside here. So if you had 5 here, then you have 5 natural log x plus 2. Now notice that as for this, when we differentiate x, we're actually going to get 1. And that's why we don't see the 1 being indicated here. And this is the end of this fundamental. Now we want to enter into the work itself.